In this video we're going to look at the cosine rule. The cosine rule is useful in places where we can't use the sine rule, because, for example, because we don't have a side and an opposite angle together somehow. Generally, what happens with the cosine rule could be that you have a side, another side, and you have an angle between them, and then you're asked to find out the third side, the side that's opposite the angle you're given. So you're given these two sides, for example, and the angle in between them. You can then find out the third side. Another alternative for the cosine rule is that sometimes you're given the three sides of a triangle and you have to find out one of the angles. The cosine rule, or a version of the cosine rule, can be used to do that. And in this first page, if you're interested, you could read through the proof of the cosine rule. It really just involves putting in, a height like this, an altitude, and then getting a couple of different expressions for the height and equating them. In any case, you'll end up with this thing down here, which is one version of the cosine rule. And it doesn't matter if you've got an acute triangle or an obtuse triangle, you'll end up with that same expression, that same thing. And then there are alternative versions of that. Now you just need to really remember one of these. My favorite one to remember is this one down here, because if you forget about the part over here and just look at the c squared equals a squared plus b squared, well, that's just Pythagoras. So it's really just the Pythagorean theorem minus 2ab cosine c. And in fact, if c, right, the angle opposite the hypotenuse, is 90 degrees, this disappears because the cosine of 90 is equal to 0. Okay, so this would be my favorite. You can rearrange it so that it looks like this if you want. So this equation here would be useful if you were given A, B, and C, this three sides of a triangle, and you had to find out the angle C. This one here is useful if you've got two sides of a triangle and the angle in between them, and you need to find out the third side of the triangle. And we'll see that an example of that on the next page. Right, in example 1, we're given various little bits of information. We're given a side here, right? This side right over here. We're given this side here. We're given, crucially, we're given the angle in between them. And then what we're asked to do is to find out this side over here, right? The one that's opposite it. So one version of the cosine rule would look a little bit like this, right? Again, you probably just have one version of this in the exam. We'll probably give you the cosine rule, and the cosine rule that you might be given might be c squared, might be c squared equals a squared plus b squared minus 2ab cosine c. As long as this capital letter here is the same as this small letter here, as long as there's a match there, and as long as these two sides here are the other sides, then you're okay. So it could be c squared equals a squared plus b squared minus 2ab cosine c, or it could be a squared equals b squared plus c squared minus 2bc cosine a. This letter here, this capital letter, has to match, has to be the same as this small letter over here. Okay, plug in our values in. If we put the 6.3 in place of the C, and the A, that's 7.2 in place of the A, and the 43.5 in place of the B, what we should end up with is something like this, right? So b squared equals that. You can then do something with that. You can then do that calculation so that b squared is equal to 25.7. And so to find out what b is going to be equal to, just do the square root of that. And the square root of 25.7 is roughly 5.07 to 3 decimal places. Now, if you're asked to solve a triangle, it means you've got to find all the missing sides and angles. So in this example 2 here, there are a bunch of things that we need to find. We've got to find the 3 angles here, given that we've already got the 3 sides. So the cosine rule actually helps us to do this. We don't need any angles to start off with. If we get given the 3 sides, that's enough for us to be able to figure out the angles that we need. Okay, so what we can do is use this formula here, except perhaps it might be better to rearrange that formula to something that looks like this. Again, the main thing to notice is that this letter here, this x, has to be the same as this x over here. Okay, so if you want to find out angle x, the steps are just to plug in x, y, and z, x, y, and z in here. If we do that, what we'll get is this, that we'll get cosine of x equal to 0.83333. And then if we want to find out what x is equal to, what we've then got to do is to do the inverse cosine of that to get 33.6 degrees. Okay, so we've now got angle x. We've got this angle in here now. It's 33.6 degrees. And you can do the same thing again. It's also possible to use the sine rule in the next step, but the cosine rule is probably a better option for us. So we use the cosine rule again to find one of the other angles. So what we can do in this case would be to try and find y by using this equation, or a converted form of that. If you plug in values of x, y, and z into this, it's the same values but now in a different order. You'll notice, instead of 7 squared plus 9 squared minus 5 squared, like we had up here, it's 5 squared plus 9 squared minus 7 squared. So it gives us a cosine of y equal to 0.633. The next step, again, just do the inverse cosine of that to get 50.7. And then when we've got 50.7, that tells us that y is going to be 50.7. We already had x, which was 33.6. So we can then use the fact that the 3 angles should add up to 180 degrees to calculate the angle z. So angle z should be 95.7 degrees. In this example, example 3, it is possible to use the sine rule or the cosine rule in this example here, because if you want to find out what z is equal to, this side here, it would be possible to use the sine rule with this side and this angle and this side to figure out what this angle would be. So you'd figure out this angle, these 2 angles away from 180 would give you this angle here, and then you could use the sine rule again because you've got the angle, you're looking for this side, you've got a side and you've got an angle. So you could use the sine rule eventually to get z in this one, but slightly more quick would be to use the cosine rule. So the cosine rule would be something like this, right? You would have the 6 squared equal to 13 squared plus z squared minus 2 times 13 times z times the cosine of the angle in between them. Now, this thing here isn't a particularly nice thing, but it is actually a quadratic equation. Right? And if we rearrange it, possible to rearrange that equation so that it looks like this. You can see that we've got a quadratic equation with an a equal to 1, a b equal to whatever minus 26 cosine of 22 degrees is. That will give you a big long decimal, and then a c equal to 133. You could just, at this stage then, use the quadratic formula to solve that. Right, so you'd figure out the determinant, the b squared minus 4ac, that's 49.1. So you know that the square root of that's going to be a roughly 7. So in our next step, the quadratic formula itself is going to look like this. So you're going to have negative b, which is going to be positive 26 cosine 22. That's from the negative of the b that we have here, plus or minus the square root of b squared minus 4ac, all divided by 2a. If you do that calculation, what we should get are these two values here, 8.5 and 15.6. Now it's interesting in this question that we actually have two possible answers. If you look at this shape here, the things one of the things that's fixed is this 22 degrees that we've got in here, and the 13 is also fixed. If you imagine that you've got a line here, a kind of dotted line here, and a line going up like this, and you start to draw 6 in like that, well, drawing it like this isn't actually the only way that you could draw your 6 from here down to this line. You could also draw 6 from here down to about here. This line that I'm tracing out in the red would be also something that would be a line of length 6. If I drew it like this, I would get the shorter length of z. If I draw it like this, I'll get the longer length of z. And that's why we get our two different possibilities there.